Today I'm going to take a look at PowerShell. PowerShell is a task automation and configuration management program developed by Microsoft, first released in 2006. It consists of a command line shell and a scripting language. It is built on top of .NET, which is a cross-platform framework also developed by Microsoft. Since Windows 10, PowerShell replaced the old command prompt. I found out about this language at my work. I had to give support to a coworker in making a PowerShell script which basically connects to different machines and execute commands. At first I thought it was like the old command prompt with a few new commands. I was really surprised when I found out that it's not only a command shell, but it is actually a full script language. You can have variables, arrays, functions, classes, modules, control flow, and many other features. It's pretty much a full programming language. When I found out that PowerShell is built with .NET, I wondered if it would be possible to interact with C# code. Turns out it is possible by using the command add_type, which adds a .NET class to PowerShell. If I wanted to interact with a C library like Raylib to make a game, all I have to do was write a bit of C# code that implements Raylib structs and functions wrapped inside a class. Thanks to interrupt services, C# can access Raylib's code from the DLL file, and with that I can access Raylib from PowerShell. I had to add the unsafe parameter to the compilation due to the code using pointers. Then I created a few helper functions to make rectangles, colors, and vectors. Having done that, it is now possible to make a game. So about the game, I made a simple snake game, but instead of eating food, you have to solve simple equations by eating the correct number or operator. As you answer correctly, the snake grows and it goes a bit faster and the equation gets a bit more difficult. The game can be split into the player and the equation generator, and also the main loop that put the two together. Here we have the snake class. Here's where all the variables are defined with their types. The body of the snake is an array of rectangles. By default, arrays in PowerShell are declared as system array, but in this case I use ArrayList from system collections. I'll explain why in a bit. The movement is pretty simple, a chain of if to check for the different keys and move. Note that the logical operators must be prefixed with a dash, just like the comparison operators. Equals is dash EQ, not equals is dash NE, and so on. All of the collision detection is done the same. Loop through the array of rectangles and call the collision function defined in the Raylib module. Note how when calling the function there is no parentheses or commas. That's because the function behaves like what PowerShell calls commandlets, which have support for positional, name, and optional parameters. It is important to remember that this doesn't apply to methods from modules, which must be called with parentheses and commas. The movement of the snake is also pretty simple. Wait for a timer to reach to 0, then move the head, which is the first rectangle in the array, to the new position. Remove the tail, which is the last rectangle, and put it in the head's old position. The reason I'm using an array list and not a simple array is because it is not possible to remove and insert element like this in a regular array, since it is immutable. The switch case is similar to other languages. Something strange I found is that if your variables to be matched are enumerators, you must wrap them with parentheses, but any other type of variable doesn't need them. According to the documentation, this is necessary because otherwise the switch treats the enumerators as a literal string for whatever reason. Good thing the Visual Studio Code debugger works because it took me a while to figure that out. Let's now take a look at the equation generator. The first step is to select random numbers and operators. Note the comma here. This is because I want to push the whole array to the array list, and if the comma isn't there, the array gets unrolled and the values are inserted separately. After creating the equation, I want to apply certain rules to the operator so the equation is easy to solve. The remainder of the division must always be 0. Multiplication should not result in huge numbers, and subtraction should not result in negative numbers. My first approach was to use the shunting jar algorithm to get the equation in the reverse Polish notation, which I already studied in a previous video. That way, it was easier to parse the operation and change the values accordingly. But I had some issues with this method, so I decided to go for a simpler solution. Loop through the token list starting at 2, the second number after the first operator. Get the first number, the operator, and the second number, and then evaluate the operator. If it is multiplication, the second number must be between 1 and 10. If it is division, the second number must be a randomly selected divisor from the first number. And if it is subtraction, the second number must be between 1 and the first number minus 1. Once this is done, I randomly select either a number or an operator to be the unknown value to discover. And then I create a string to show to the user, replacing the unknown value with an underscore. To get the result of the operation, I use the command-let invoke expression, which executes a string as a code and returns the result. Finally, the last thing is to add different answers to show the player. First, I add the correct answer to the top of the array. If the unknown value is a number, the other answers are the correct number plus or minus a randomly selected offset. And if the unknown value is an operator, I simply set the other answers to the other operators. After that, I shuffle the array by using something known as a pipeline. This allows you to combine different commands, which is very common in shell scripting. Here I pass the array to the sort object command-let and set it to order it at random. Finally, I set the answers x and y position. So finally, let's now look at the main script. First, I did a couple of things, so using this language is a bit easier. Set the strict mode to version 3.0. This adds a couple of rules to the language, so it will raise an error if you try to do things like, for example, out of bounds array index. Then I set the error action preference to stop, which means PowerShell will stop at the first error. Sounds a bit weird, but PowerShell has a thing called non-terminating errors, which, as the name implies, doesn't terminate the execution of the script. Since we don't want that behavior, we remove it by setting this variable. Now, here's another weird thing to add to the list of PowerShell weird things. You can import a module by using the command-let import module and the path of the module, which, yeah, makes sense. But what if you want to include a regular PowerShell script? We have to .source it. This feature lets you run the script in the current scope so you can access all of its functions and classes. This syntax is a bit weird, but I guess it's easier to type in a command line interface. The rest of the code is as how you would expect, initializing Rayleigh, variables, and the main game loop. So yeah, that's about the game's code. PowerShell is great as a shell scripting language, at least compared to batch files. It obviously was never meant to be used as a general purpose language. Any sane person will tell you to use any other from the .NET languages like C Sharp, Visual Basic, or even F Sharp. And there isn't any reason to use this language other than automate boring stuff. And yeah, I agree. On top of that, the language isn't the most performant in the context of making a game. Again, this language was never meant to be used for things other than executing a few commands, maybe reading files, and that's it. Also, the PowerShell version I use is 5.1, which is the one that came with my Windows. The latest version at the moment is 7.3.6, and maybe that version has better performance or fix those gotchas that I found in the version I'm using. I don't know. So yeah, that's about it. PowerShell is a really interesting language, but I probably won't use it in making any other thing that isn't automating stuff. Thank you very much for watching.